Hey guys, so in today's video we're going to talk about climate change. We're going to go in very briefly about it, but I want to talk about the difference between weather and climate, some different ways that we make the greenhouse effect, what the greenhouse effect is, how it is naturally, and what we have done to amplify it. I want to go into the different types of gases that are causing this, and yeah, that's about it. Maybe some climate change evidence. We might get into that. Okay. The first thing I want to cover, though, is the difference between weather and climate. I don't really know what I'm going to write down for this, but I'm holding a marker anyway because it makes me feel professional. Weather is something that is one time, like the day-to-day state. So if you wake up in the morning and you say, oh, well, what's the weather today? Is it raining? Is it going to be cold? Is it going to be, that's the weather outside, temporary. Climate is the gradual increase, well, that's not good, but the increase of something overall. So if somewhere it was raining every day for years, that is now the climate, right? I wrote down a definition here. Average weather conditions over a long period of time. Yeah, so something that is the same for a long period of time. That's the difference between climate versus weather. Now, the natural versus anthropogenic, that's a thing, greenhouse effect. So, the natural greenhouse effect is the sun's rays. Actually, I can draw something for this. This is kind of cool. This is our Earth. Oh, the Earth does not look like that. Don't quote me. Damn. Okay, so this is our Earth. Our lovely little Earth. And this is the sun. Actually, let's do it like this. Ha 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 ha. The sun. Okay. And the sun, can you even see that? I need new markers. Maybe I can write in purple. Would you guys see purple better? But the sun sends rays down to our Earth. And our Earth has this thing around it called the atmosphere. Alright? Some of the Earth's, the rays from the sun, okay, will come and hit the Earth. And this will then bounce off and shoot back into space. Now, this atmosphere collects some of it and allows for some of these rays to stay within the atmosphere. Now, this is really neat because what this does is it allows us to heat the Earth naturally and allows for life to live there because we need this average temperature for us to be able to survive. What was that about? Yeah, that's a natural greenhouse effect. That is the greenhouse effect. But the anthropogenic, we're going to say that's what it sounds like, but that's not what we do to it. This is how we amplify it. So this happens by, human activities. So us burning fossil fuels, like different things like that. It's mainly the emission of gases. So the different gases that we put into the atmosphere that allow for more heat to be trapped into it. Not good. Not good. Okay, yeah, so we're going to go into some of these gases. The first one is the most prominent and is mainly what it is, CO2 or carbon dioxide. This is emitted by burning fossil fuels like coal and oil and deforestation. Now, in a lot of places it has been made illegal to burn fossil fuels. In a lot of places we use hydropower instead of burning fossil fuels. There is a lot of places where it is not mandatory, and it is in those places that the air is really bad, and some people may have to wear masks. What that is doing is it is putting fossil fuels into, this is our beautiful atmosphere around our Earth. I don't know why I drew it to the side, but it's emitting fossil fuels into here, and it is allowing for more heat to be absorbed into our atmosphere to heat up the planet over time, which isn't natural. I mean, some people may say climate change is natural, but while climate change is natural to an extent where we have heat flares and, then we go into the Ice Age, yeah. But over a long period of time, this is rapidly increasing. I mean, over the last 100 years or so, we have had a drastic increase of everything related to climate change. I mean, the fossil fuels being burned, but the carbon emission mainly, and man, like, the planet's been around for 4 billion years, and we have only been around for a very, very small amount of time on that. Seconds compared if we put the Earth into an hour. And we have destroyed it because of that. Like, it's just the fact that we have been around for so little time and yet have changed so much. And that's what climate change is when it is, well, amplified by us. So some evidence of climate change, I could say, are the glaciers are melting due to the temperature of the Earth rising. We know that. The polar bears are all dying because of the icebergs melting, which it's not good. Another thing is extreme weather, because the increase of heat allows for more moisture to be absorbed. So we have more weather conditions and higher sea levels. It's not good. We're only at 6 minutes. We're only 6 minutes. Maybe we can go into convection currents, because this is the way that the air and, well, it's not just the air, but like how air and water travel around the Earth to equally heat it, mainly. Now, when talking about this is actually really neat. So when the rays of the sun go down to the surface, okay? And at that point, the air is heated. We're talking in air right now, but the air is heated. And when air heats up, it gets lighter. It gets less dense. And so it allows it to float on top of all the other air and up to the surface where it cools down. Not the surface, but up to the bridge of the atmosphere where it then cools down. And when something gets cooler, it gets more dense, more heavy. And then it will fall back down to the Earth. Let me describe this with a diagram, because this is actually really neat. Convection currents. We've got a nice little Earth and our atmosphere. The sun's rays will come down and bounce off here, and it will heat this air up. And then it will make the air less dense, which then moves the air to the brim of the atmosphere. And that will then cool it down from up here, this space, which then will make it more heavy and bring it back down. And what this does is it pushes the air around the Earth, it recycles it, it helps it out. And this is the same thing with water. Where's my eraser gone? Here it is. How when we have a river, or whatever, a lake, here's the surface, and here's the floor. Maybe a nice little starfish. Can I draw a star? Yes, we can. Okay. This water, at the surface, the sun is beaming down on it. Okay? And this top layer will... Sorry, I forget that. Well, okay. Water will get hot. Okay? And it'll warm up and it'll get sent to the surface, where it is then cooled down and sent back down. Up and then back down. And this lets it travel. And it can travel back. And how this happens, again, is because colder things are more dense. So, I know that might sound a little bit confusing, but when something is colder or has an absence of heat, it is a lot heavier. It is a lot more condensed. But you can think about it as, what's a good example of this? I don't know a good example. I was going to say, water turning into gas, but steam. But that's not really the same thing. But, like, it's a good way to kind of think about it. How water is, like, really dense and stuff, then it heats up and then it gets lighter. But it's kind of how, not really how that works, but still, like, you know, when something is colder, it gets more smushed together. And then when it lightens up, you know, that's why they say hot air rises. That's why. Maybe we could talk about, so, okay, we are 10 minutes. I'll probably just make one climate change video, because climate change is not really my style, but there is some things that are important. Climate change is really important, though, to learn about, so we're going to make this video anyway. Carbon cycle is what I want to go over next. The carbon cycle is the cycle of carbon, which is similar to convection currents, but this is a lot more manual. Not by man, but, like, a lot of things need to go in to make this work. So, it's the natural cycle of carbon. Okay, the first thing is photosynthesis. I can never say that word, but we have a plant, which then puts CO2, no it doesn't, it takes CO2 in. Yeah. It works with CO2. Yeah. And then we go down to decomposition, which is the breaking down of plants to make fossil fuels. This happens over millions of years. It's a long time. It's why we have oil and stuff, and it's why it's so dark, like deep into the earth, because over a while these plants and stuff are condensed and turn into fossil fuels, but a while, like a long time. Respiration, things like, so this takes in the CO2, right? Decomposition is like plants being decomposed. That's a great picture of decomposing. This is to make fossil fuels. I don't know why I'm drawing this in a circle. It doesn't really work in a circle. But, and then we have the respiratory, which is how things breathe in oxygen and breathe out CO2. We breathe in the oxygen. Us. Smiley face. And we breathe out the CO2 needed for the plant. And then there's combustion, which in this case is something that we've done, which is the burning state of CO2, or how we burn all these fossil fuels to make a lot more CO2. Not good. The last thing, though, I want to talk about is carbon sinks, which is a really brief thing, but carbon sinks they can be a few different things, but their job is to absorb and use more carbon dioxide than they put out. So a carbon sink, it is something that disposes of all of our carbon. Well, not really, but, you know, it disposes of a little bit of it. It takes in more than it puts out, so they're good for our mass of carbon that we're putting into the atmosphere. Not so good. Besides that, I think I'm done for the day. You guys will see my new poster. I think I showed that last video, but I got another one. Woo-hoo. That one too. Super cool. Alright, rock on, you guys. Have a great day. Go touch some grass and go look at the stars.